In this video, I will be demonstrating the use of a TI-83 Plus calculator and the ExcelPivot spreadsheet for solving system of linear equations. Let's say we have a following problem that we want to solve. Cantrell Associates is a real estate developer, is planning to build a new apartment complex consisting of one-bedroom units, 2- and 3-bedroom units. A total of 192 units is planned, and the number of family units, that is 2- and 3-bedroom units, will equal the number of one-bedroom units, and the number of one-bedroom units will be 3 times the number of 3-bedroom units. Find how many units for each type will be in the complex. Well, we can take that problem and formulate it. And we can formulate it as follows. We'll let X, Y, and Z denote the number of one-bedroom units, 2-bedroom units, and 3-bedroom units respectively. That is, X is going to equal the number of one-bedroom units, Y is going to be equal to the number of 2-bedroom units, and Z is going to equal to the number of 3-bedroom units. We'll now translate the verbiage in the word problem into 3 equations. The first one translates the total number of units planned is 192. So if we add X and Y and Z, we'll get 192. A second equation we can form comes from the phrase that says the number of family units, that is, the number of 2- and 3-bedroom units, is equal to the number of one-bedroom units. So we could translate to say if we had the number of one-bedroom units, we subtract the number of 2-bedroom units and then subtract the number of 3-bedroom units. Since X is equal to the total number of X plus Y, we get X minus Y minus Z equals 0. And finally, the phrase that says if the number of one-bedroom units will be 3 times the number of 3-bedroom units, if we took X and subtract 3 times Z, which is the 3-bedroom units, we should get 0 as well. Well, once we have our 3 equations, we can make up an augmented matrix. And you'll recall the augmented matrix is made up of a coefficient matrix, made up of the coefficients of from the left-hand side of the system of equations. So our coefficient matrix would be in column 1, 1, 1, 1, being corresponding to the coefficients of X. Column 2 would be 1, negative 1, 0, corresponding to the coefficients of Y. And since the third equation has no Y, we put a 0 in there. Finally, the third column of the coefficient matrix will be 1, negative 1, negative 3. We add to that coefficient makes it a 3-by-1 matrix made up of the constants 192, 0, and 0. Our next task then is to reduce that. Before the video began, I took the augmented matrix that I was going to need, and I created an augmented matrix in the Excel spreadsheet titled Matrix Pivot. And you will see in columns 1, 2, and 3, I have transcribed the elements of the coefficient matrix in the augmented one. And then I transcribed the constants from the right-hand side of the vertical line in the augmented matrix. Now, in the past, we have reduced this matrix by performing a series of row operations, as Gauss-Jordan indicated we could do. But what I would like to introduce you today is some additional function this spreadsheet has. You'll notice the box says Pivot on Selection. What it's saying is select the pivot point, and then I will pivot about that point. So if I would select that first column, and when I did so, I said Pivot on Selection, the spreadsheet will take and will reduce that column, according to the Gauss-Jordans, into a unit column. My next step would then be, once I'd reduced the first column, I'll reduce the second. So I'll select a pivot point in row 2, column 2, and say pivot about selection. And you notice that became a unit column. Finally, I will pivot about the third column. I want to make that a unit column with a 1 in row 3, column 3. So if I select that as the pivot and pivot about it, you see I have a row reduced echelon form of the matrix, and in column 4 I have my constants that constitute the solution of the equation. I'm now going to show you how to use your TI calculator if your Excel spreadsheet is not available. In order to do that, I'm going to have to store the matrices. In order to do that, if you'll look at the key third from the top on the left, it has an X with an exponent of -1. But in blue written above that is the word matrix, and that's telling you that I can get to the matrix menu by clicking the blue button or the second button and then the X with the exponent. Just to the right of the simulated calculator is a key history, in case you can't see it clear enough. Once I've done that, it brings up a menu that says I have got names, and if I go to the right, it lists a bunch of math functions that are built in, and finally to the edit. What I want to do is I want to edit matrix A, and I want to make a 3x3 matrix that's going to contain the coefficients from the left-hand side of the equation. So if I hit enter there, it now opens up a box, and there's matrix A. Matrix A has a dimension of 3x3, which is what I want, but if I didn't have that, I could place in the number of rows and the number of columns. So I'll accept 3 rows and I'll accept 3 columns, and then it'll now scroll through where I can put in the values in the coefficient matrix. Upper left corner is 1. I'll keep that one. I hit enter and it moves to the second. It's also a 1. I'm good there. Enter again. I put in the third row and third column, it has a 1 as well. So I'll accept that and hit enter again. Okay, it now goes to row 2. Well, the 1's okay there, so I'll hit that and enter. In row 2, column 2, however, I want a -1. So I will insert there my -1 and enter, and it'll put it in the box. In the third column in row 2, I also want a -1, so I'll enter -1 and place enter. Row 3 has the 1, which I'm okay with. The second one I want a 0, so I'll enter a 0 in it. And the third one I want a -3. So now my matrix is now filled with the corresponding elements in the coefficient matrix. I'm going to exit out of that, and now I'm going to define another matrix. So I go back to the matrix menu, but this time I want to define matrix B. So I'm going to go to the edit menu and go down to B, and you can see B is currently defined as a 3x1, and that's okay, that's what I want. So I'll just leave it and just move on through. But in the first row, first column of this 3x3 matrix, I want 192, so I'll place 192 and place enter. In the second one, I want a 0, so I'll say 0, enter. And in the third one, I want a 0, so I'll enter 0 and return. Now matrix B has the filled with the constants. Exit the menu again, and now I want to form my augmented matrix. So I'm going to go to the matrix menu one more time. This time I'm going to go to the math functions, and you see the math, and number 7 you will says augment. That's the one I want, because what it will do is we'll take one matrix and augment to it another matrix. So I'm going to say augment. And what I want to do is I want to take matrix A, so I select matrix menu again and say matrix A, and it puts it in there. I'm put a comma, and 2A I want to augment with matrix B. So I click the blue button, matrix menu one more time, and I want to select matrix B, and I'll place it in there. If I now hit return, it will now take and augment A with B, and if you can see the little arrow written there, it says I've got more columns, so if I'll slide over, you will see there is matrix B. Okay. Before I leave here, I want to do one special thing, because this is just stored in memory, and when I erase it, I'll lose it. So what I want to do is I want to store that augmented matrix in some place, and I'm going to store it in yet another matrix. So I'm going to second menu. I'm going to press the store button. You'll see it lower second from the bottom on the left. If I press store, it's saying it's going to take the answer and store it someplace. Well, I want to store it in matrix C. So I will now select second matrix menu again. But this time I want to select matrix C, and I want to take the results from the previous answer and store it in C. If the dimensions of C were different, store would overwritten it. So if I did that, I've now stored that value in matrix C. Now I'm ready to solve. So finally, I now go again to the matrix menu, but this time I go to the math submenu, and I'm going to scroll down until I get to a function that you're familiar with, or at least the phrase we're familiar with, and that is row reduced echelon form, RREF. If I select that function, it places that on the screen, and it's telling me which matrix do you want to be row reduced. And I go back and say I'm going to select, and I want matrix C, number 3, and then when I hit a return, it row reduces that matrix. And if we will scroll to the right to see what the last column is, we will see indeed it is. Well, I wrote using the Excel spreadsheet or the TI calculator, I reduced the that matrix to that one there. And from that we can read off our answers. X is equal to 96, Y is equal to 64, Z is equal to 32. That means that the Caldwell Associate Realtor is going to build 96 one-bedroom units, 64 two-bedroom units, and 32 three-bedroom units.